Welcome to this video. In this video, I will be talking a bit more on the inverse relationships of your exponential functions and your logarithmic functions. And then after that, I'll be talking about a few more special properties of your logarithmic functions and graphs. Okay? Alright, let's get started then. Okay, so here you see f of x is equal to 2 to the power of x, and g of x is equal to log x to the base of 2. I want you guys to try to pause the video and try to find the inverse. Alright, so find the inverse of f. Find inverse of f and find inverse of g. Okay, so give that a try. Alright, welcome back. Now I'm gonna show you guys how to do it. I hope you have tried it already. Okay, so when we are finding inverse, we learned how to do this in chapter 1, and hope you guys still remember. If not, take out your notes. Go ahead, use your notes to help you out. So the first thing that we should do is to replace the f with the y, and then next we're going to switch the x and y, and then we'll try to somehow make y the subject. So here my y is in the exponent. I will need to, we learned about this in the previous video, where I can use log to cancel out exponential, and I can use exponential to cancel out log, right? So here I'm going to erase this line. I'm going to say, okay, this is 2 to the power of y, this is x. I'm going to give myself some space. This should be log 2. Oh, let me write that better. So I'm going to log 2 to the power of y, the whole thing to the base of 2, and I'm going to do the same thing to the left hand side. Alright, so we already learned how to do this in the previous videos, right? When we were solving logarithmic equations. Okay. Now let's proceed. So since this will cancel out, this is gonna go on my right hand side. I would only have just y, and on my left hand side I will have log x to the base of 2. Alright, so now I have just isolated my y, and I can replace my y with my inverse. So my inverse of f is log x to the base of 2. Okay, now I'm not sure if you guys saw this. Isn't that my g of x? Okay, so we'll try to do the same, pretty much the similar steps. We'll carry out similar steps, but now to find the inverse of g. Okay, g inverse. So let's give that a try. So y is equal to log x to the base of 2, and then I'm gonna say, okay, switch my x and y. Alright, and now I need to somehow isolate my y, and my y is right now my y is in a logarithmic function. I need to use the exponential function to cancel it. So I'm going to say 2 to the power of log y to the base of 2. So exponential functions and logarithmic functions, they cancel out each other. So I'm going to do the same thing to the left. So the 2 and the log 2, they're gonna cancel each other. So on my right hand side, I'm just gonna have y, and on my left hand side, I will have 2 to the power of x. And now I can bring back my inverse of g is equal to 2 to the power of x. And I'm not sure if you guys see this. Isn't that my f of x? Okay, so that, I hope you guys find that somewhat cool, right? So now that we know how to find the inverse of an exponential function and of a logarithmic function, let's try to put them into each other. Okay, so here I'm going to change my color and I'm going to use blue. So let's say if I have f of g of x, okay, which means I'm going to put g in my f, right? Let's try to do that. So I have f of my g of x is here. That's my g of x. So I will have, and my f is over here. So I'm gonna put this log x to the base of 2 here. Make sense? Because this is my f of x, and then I'm replacing my x. I'm replacing the x with log 2x. Sorry, log x to the base of 2. So this will be changed to log x to the base of 2. So here, that's my expression. Alright, this is my f of g. Now, 2 to the power of log 2x exponential, and then the exponent has a log. They will cancel out each other, right? So I will have just x. Okay? Now, let's try to do the same thing, but now I will have g of f, which means I'm going to put f in my g. So I have a g, and then inside I will have a 2 to the power of x. Okay? So my g of x is over here, and I'm going to have log something to the base of 2. And since I have replaced this x here with 2 to the power of x, I can also replace the x here with 2 to the power of x. So I will have 2 to the power of x over here. Make sense? So now log and exponential, again, they cancel out. Keep in mind that the bases are the same, right? This is a base of 2. This is also a base of 2. That's why I can cancel them out, and I would get x as well. So as we can see, when we put the f of g of x, that gives us an x. When I put g of f of x, that also gives us an x. So f function f of x and the function g of x, they are inverse of each other. Okay, inverse of each other. Alright, we can I hope you guys understand what has happened in the past 7 minutes, 8 minutes. Feel free to rewind. Okay, it is very important that we know how to find inverse, and we learned that in chapter 1, and you need the scale to find inverse, to apply the scale on different type of functions. And now in this chapter we're talking about exponential and logarithmic functions, so the scales would still apply, and you need that. Okay, so in next I'm going to talk about how can we visualize this inverse relationships on using their graphs. Okay, so if you're not sure, please take out your chapter 1 notes, do a little bit of review on what inverse functions are and what are their relationships, and then you can come back to this video later. Okay, alright, I'm gonna continue. So I'm gonna bring up my decimals. So here I already have my g of x is equal to 2 to the power of x. Actually, I should change that to f. Change that to g. Okay, sorry about that. Now, my f of x is 2 to the power of x. So you can see that I have a special point, that point 0, 1. When my x is equal to 0, my y is 1. And we have this should not be the first time we've seen this graph. So this blue line is my 2 to the power of x. And we also talked about this in the previous video about the asymptotes. So you can see that as I go to the left, my y value becomes smaller and smaller, but it will never touch the x-axis. So I'm gonna have a horizontal asymptote there for my exponential graph, right? This was discussed in the previous videos. Now, I'm gonna show the g of x, which is log x to the base of 2. Right? I'm gonna show that graph. But just now, when we in the beginning of this video, we already analyzed on the relationship between exponential functions and logarithmic functions, and we learned that they are inverse of each other. So, what do you think? Can you make a prediction? Can you make a prediction on how the graph of log x to the base of 2, this g of x over here, how do you think that graph is going to look like? Can you make a prediction? Pause the video, take a guess. Okay, now, if they are inverse of each other, in chapter 1, we learned that they must be reflection of each other along the y is equal to x line, right? This green line that we have here. So if they are inverse of each other, then they will be reflection of each other across the y equals to x line. So this 0, 1 is now should be the 0, 1 point that we have. That is gonna be where at. If it's inverse, we switch to x and y, so that would be at 1, 0. And we'll see if that's true. And also, there was a point for the y is equal to x, for the f of x. There was also a point where when x is equal to 1, my y is equal to 2. See that? X equals to 1, y equals to 2. So I'm going to put that point down as well, just as a point of reference. Okay, so this is my 1, 2. And now that point is going to be at 2, 1. Okay. Alright, so I'm going to show you guys how the log x to the base of 2, the g of x, how the graph look like. I hope you guys have already taken a good guess. There you go. The red color line, that is the graph of my log function. Okay, that's the log x to the base of 2. And as we predicted, since the inverse functions, the graphs of the inverse functions, there will be reflection across this y equals to x line. So as what we see right now, it does look like reflections of each other across y equals to x. And also when we have the inverse, the x and y switch, right? The x and y will switch. So 0, 1 became 1, 0. 1, 2 becomes 2, 1. Right? What do you think about the asymptote? So now I'm going to remove the exponential graph. If you look at the if you look at the logarithmic graph, the red color, log x to the power of 2. If you look at the graph, the red graph, what do you think? Is there asymptote? Is there an asymptote? There is. Asymptote seems like, so if you see, if I move this to the right, if I move it to the right, you can see that my if I go towards the right hand side of the graph, let me try to get, okay, there you go. So I can keep on going to the right, and if I keep on going to the right, my y will increases slowly, right? But it's just gonna keep on increasing. But if I go to the left, as my x gets very close to 0, you see what happens to, so my y becomes very negative, very negative. So if I go to the left hand side of the graph, it seems as if it's going to touch the y-axis, but you only get closer and closer to, though. If I keep on going down, you can see that even though it might seem as if it's touching, but it's not really touching, because it just gets closer and closer. Okay, which means we have a vertical asymptote. So a log function would have a vertical asymptote, whereas an exponential function would have a horizontal asymptote. Please keep that in mind. Maybe you should write down your notes, okay? So exponential functions have horizontal asymptote. Log functions have vertical asymptote, which means in chapter 1 we learned that horizontal asymptote plays a role in our range. So when we are figuring out the range of exponential functions, we have to be careful. And logarithmic functions, we have a vertical asymptote, and vertical asymptote plays a role in our domain. So we have to be careful with our domain for the log functions. Alright, hope you guys understood the second half of this video. This video is quite important. It's very conceptual. And if you need to rewind the video, please feel free to do so. Any questions, bring to class, and I'll see you in the next video. Bye bye.